This is a video where I'm illustrating how I set up a VPL module for my Intro to CS class. The class is taught in Python. The students have to write Python programs. So I've set up a system where I'm using VPL, Virtual Programming Lab. And I'm assuming that the students are writing Python 3 programs, and in this example, their assignment is to write a program called lab9_2.py. And to test this program, I have actually a set of 4 different Python programs that will be used by the VPL module to test the student program. Evaluate2.py is a program that I wrote. It's fairly extensive, and basically it runs the student program as a sub-process. Try to catch all possible exceptions that could be generated. And make it generate some output for different inputs. You can specify up to 5 different input files or input standard ins for the program. And Evaluate2.py will also run the solution program that you have to write as the instructor, and we'll submit it, we'll energize it with the same 4 or 5 different inputs that are specified in this file. So params.py is a file of parameters. So basically this file never changes, this program never changes. This one changes with every assignment, and there's many different options that can be activated in here. So basically the only work that has to be done by the instructor is to update params.py to the new assignment, write a solution, and that's it, and do some testing. And PyMinifier is a program that has been written by, whose name I will mention later. And basically it's a program that will strip Python of all comments. It's pretty clever the way it does that, so that it will look at strings and will not remove comments that could be in string if you have pound signs. So PyMinifier remove also any extra space, really makes the Python program as tight as possible, and it's a very good way to test if the student is using particular functions or defining particular functions. It's easier to test on the output of PyMinifier whether the student program contains particular patterns of interest. All right, so my setup is that I'm using Eclipse. I find Eclipse to be a nice environment for keeping track of all my programs for a particular class. So I have all the different labs, the parameter file for the lab, the program and the solution, and the same for the homework assignments. So evaluate.py is right here. This is a program that I have written that contains about 1,000 lines or so. I'm happy to share it if you send me an email. And this file will look at the file called params.py, and this file contains all the parameters that define that particular assignment that is being tested. For example, the module name is lab9_2, solution file name lab9_2 salt. The .py is assumed automatically. And then plenty of booleans. Remove blank lines, can set it to true or false. Remove comments, set it to true or false. Remove extra space in the output, true or false. If you want to add if name equals main to the student program, you can specify it, and evaluate2.py will automatically add that to the program, to the student program, allows for particular types of import. However, if you want to strip it, and in case the student will have added it and want to strip it, you can also set this true. If you want to sort the lines output by the student program as well as the solution program before comparing the two, you can also set that. Anyway, plenty of different parameters. The grades also, the lowest grade, the highest grade possible, whether you want to grade linearly with the number of correct output lines. And then data files. In this particular example, actually I want to use 4 different data files. the data files will be cats1.txt, and that's the contents of that file, cats2.txt, and that's the contents of that file, cats3.txt, and that's the contents of that file, and I have a cats4.txt, and that's the content of that file. So I can specify data files in here and how many I use, at most 5, but you can see that it's easy to add more. And then I need to specify, so here the student program will prompt the user what file should be open. So I have input files that will be fed to the standard in stream of the Python program. So cats1.txt, cats2.txt, cats3.txt, and cats4.txt match the name of the files that I have here. So this part will create these data files before executing the programs. This specifies what's going to be fed into the standard in for the student program to get that name and open the right file. Alright, so that's for the programs file. PyMinifier here I mentioned is written by Dan McDougall. A very nice program, quite a long program, and removes all the information that is not pertinent to Python from a student file. All right, so let's go to Moodle. And what I'm going to do is, in the week 10 section here, I'm going to add a lab 9 problem 2. I've already added it in week 9. I'm going to show you how to do it from scratch. So I'm going to add an activity or resource. Virtual Programming Lab is one of the options. I add it. Its name is going to be lab 9 problem 2. I usually skip the description. Important is a submission period. It's going to be due, so here it's enable. This particular one I want to do on Friday the 6th of November at midnight. We don't have midnight, but we have 11:55, so that's what I have. And importantly, you want to assign the grade to the right category. So in the grader on Moodle, I have created already several categories for each homework assignment and each lab. So this is lab 9. Okay, and it's going to be a letter grade scale. However, the VPL module will report a number grade to Moodle, and Moodle will translate that using its internal table into a letter grade. So I didn't change the table that Moodle uses, but the evaluate2.py program knows this table and can tell the student both the number grade and the letter grade that she gets on an assignment. So that's all I have to do, the due date and where to assign the grade in a grade book, and that I can save. Now that it is saved, I have to set the execution option. So there's several things that I'm going to have to set. Execution option, requested file, advanced settings. I'm going to have to create several files to upload to the GL server, and then test activity. I will put my student file and test it. So execution options. Run, I will not allow students to run their program. I found that this often would result in the student trying to run a program, realizing the program runs correctly, and then moving on to another part of the assignment, and then forgetting to evaluate, and in which case you would not get a grade. So it's easier to allow debug, which puts the output in a console in non-proportional font. So it's a good way for students to look at their output in different format. And evaluate will evaluate and generate a grade. Unfortunately, the output from the evaluation will be in HTML. So from spacing of characters in the output will be lost. And evaluate just on submission, I think, is good. Prevents the student from modifying their program in Moodle, and they have to go back to idle to work on their program. Automatic grade, yes. All right, automatic grade means that the grade will be automatically put in a grader, in a grade book on Moodle. Okay, option saved. And so now I have to go to requested file, and indicate what is the name that the student has to use for the file that she will submit. It's lab9_2py for this time. Don't forget to save. So it's blank, it's just a placeholder for the student file. The advanced setting, I have to define the 4 files that I will update, and also create shell files for debug, evaluate. So what I like to do is I like to have previous assignment. This is the old lab 9, and so this shell file is always going to be the same. So I can actually copy it here, save. What it does, it basically, this is the important part, it creates another script file which is required by VPL, which is called VPL execution, and that defines what needs to happen on the GL server to run the student and solution program. And so evaluate2.py will take care of everything. So all I have to do on the GL server is say, run the default Python interpreter, pass it this file, and everything will take place. So that I can use for debug, and I can use for evaluate.sh. Save. And these are the 2 files that I need to set here. I don't need to worry about the other 2. So now I need to add several files, the evaluate2.py. Okay, and I'm going to copy it from a previous assignment because it's always the same. So I could go to Eclipse, or I could go there. The params file that contains all the parameters for that particular assignment. So that I'm going to copy from Eclipse, params. Okay. I need to create the Py minifier. That I can copy from a previous assignment. Okay. And finally, my solution program for the assignment. lab9_2sol.py. Alright, and that I'm going to copy typically from Eclipse. Okay, so you can call this whatever name you want as long as it matches the name that you will have specified in the params file, and lab9_2sol is my solution file name, and that's what I have here. So I have 1, 2, 3, 4 new files that I've added. So here I have to explicitly say that whenever the evaluation is going to take place on the GL server, these 4 files should be sent over. So files to keep when running, these are the 4 files. The others will be done automatically, so I don't have to click them. Alright, so that's it for this part. So now I can test. I'm going to go to test activity, edit, and here I'm going to write my typical student program. So here I'm going to copy this, which is basically a copy of the solution. And so that typically simulates what the student will see when she submits her program. So saving, evaluate. Okay, so this was pretty fast. What happened is that this file, the solution file, evaluate.py, the params file, Py minifier, and the other 2 script files were sent to the GL server, which is a separate Linux server, was run there, and this is the output. The output, the student sees her grade, 100 out of 100, and here are the comments generated by evaluate2.py. It tells the student what the different inputs were. There was cats1.txt, there was cats2.txt, there was cats3.txt, there was cats4.txt, and then for test number 1, the program passed the test. Program 2, and basically what it means is that both the student program and the solution program had the same output. And the same was 2, 3, and 4. Congrats, your program output is correct. Your grade is A, which Moodle will translate in 100. And so if it were not, so let's create a bug here somewhere. Instead of appending this is equal to -1, let's say if it's equal to 0, that's going to generate some errors. Save, evaluate. Okay, so the grade is 82.99, and so here are the comments. So your grade is B minus, which Moodle will translate in 82.99. That's because the VPL only returns numbers, and Moodle here I've set to display grades as letters, which students seem to like better. So here we have an output that is a little cryptic, and it's going to show the output of the diff Linux command, showing differences between solution and student program. It's a little hard to understand this. That's why the debug may be a little better here. So we see that minus and plus. Minus is the student output, plus is the solution. The not here, the student output contains a not that is not in the solution. And the same is true. Bob here, orange tabby, not vaccinated, not tattooed. And the solution says that Bob should be an orange tabby, not vaccinated, tattooed. So the debug option allows a little bit more control of the output for the student to see what's going on. All right, so let me correct that. I'm going to go back to -1. Okay, save it, evaluate, and I'm back to 100 for the grade. So that's it. So in summary, what you have to do is, or what I have to do when I create a new assignment, I go to Eclipse and I create a new params file for my assignment. The solution program, lab92 sol, so basically they're the same. This one is just there to inject bugs and do some testing. And then to test whether it works, I go to evaluate and I run this. And it's going to give me here the typical output that the VPL module will generate. So I can debug my setup here in Eclipse, and then when I'm satisfied that it works well, then I can go to Moodle and create a new VPL activity.